In this video, we are going to discuss about the boundary conditions of the time varying fields. So, on the completion of this topic, students will be able to familiarize with the different concepts of this electrostatic as well as the magnetostatic properties, and also they can identify how the time is varied based on this electromagnetic system. And next one is boundary conditions of the time varying fields. So here the relationship between the electric field density, that is D vector, then electric field intensity E vector, magnetic field density B vector, and magnetic field intensity H vector, which we can explain with the help of the point form, or we can represent in the form of the integral form. So here this relationship, that is the field equation which we are postulated from the Maxwell's, are valid, so that we can write it in a continuous medium. And also this Maxwell equation, we are using this in a form of conditions that we are deterministic at the boundary surface of the two different media. So we can apply the concepts of linear, isotropic and homogeneous medium. So here we are considering the boundary equations that is present between the medium 1. So with the parameters r1, mu1 and epsilon 1, and the medium 2 if you are considering, then with the parameters epsilon 2, mu2 and sigma 2. So in generally we can say that it is the boundary conditions for the time varying fields will be same as that of the static field. E vector so is this boundary which is referring to the boundary conditions for the static electromagnetic field. The next one we can write it as component of the magnetic field intensity that is continuous across the surface. So that we call it as the perfect conductor. So that we can write the same equation in terms of the magnetic field intensity, means H tan 1 equal to H tan 2. Then next one is the magnetic field intensity that is tangential to the surface. So at the surface of the perfect conductor, this tangential component will be discontinuous, so that we can write it as equal to 0. So the normal component of this electric field density is continuous at the boundary if this charge density we are considering, that is rho, is equal to 0. If this charge density is 0, means we can write it as H tan 1 is equal to H tan 2. So from the equation we can write it as H tan 1 minus H tan 2 is equal to K. So here we are considering the surface charge density, that is dN1 is equal to dN2. If this surface charge density is non-zero, means then this normal component of this electric flux density we can say it is discontinuous. So if it is discontinuous and continuous, means this differential component we can write it as this normal component of the magnetic flux density that is continuous at the boundary. So we can write it as dN1 minus dN2 is equal to rho s. From this equation we can write it as dN1 is equal to bN2. So quiz questions on this boundary conditions of the time varying fields. That is, first one, the charge built up in a capacitor is due to which current, that is displacement current. And the second one is the surface integral of which parameter is 0, that is the surface integral of the conductor is will be equal to 0, that is magnetic field density is equal to 0. Thank you.